Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. There is another video in structural analysis, particularly on beam deflections. For the beam loaded as shown below by double integration method, determine the vertical deflection under the load P and at the center of the beam with constant T. I use the following data. A equals B equals C equals L over 3. And for part B, A equals C equals L over 4, B is L over 2. By the way, if you want to anticipate the solution to this problem, you may do so by pausing the video. That should be your attitude in developing yourselves, especially in civil engineering courses. So because of symmetry, A is equal to B equals C L over 3, then the reaction at the left support would be P as well as at the right support P. Then, because of symmetry, the deflection at the center would be maximum, and the slope there is expected to be horizontal or zero. So we don't need to section the entire beam, especially the last segment, only this portion here as shown in the figure. So EI y double prime equals P times X minus P times quantity X minus A, and A is L over 3 for part 1. Integrating EIy prime equals P over 2x square minus P over 2 quantity x minus L over 3 square plus C sub 1, the constant of integration, which is interpreted divided by EI, the slope at the left support or at the origin. Then because the left or the origin is a support, there will be no C sub 2. So integrating further, EIy equals P over 6 x cubed minus P over 6 quantity x minus L over 3 cubed plus C sub 1x. We can now evaluate the value of C sub 1 by noting that the beam is symmetric with respect to its axis and the loading also, so that when x is L over 2, y prime or the slope at the center is 0. So we can evaluate C sub 1 using this equation here. We equate y prime 0 equals P over 2 L over 2 square minus P over 2 quantity L over 2 minus L over 3 quantity square plus C sub 1. So using your calculator there, simplify this first, then minus PL square over 8. C sub 1 is equal to negative 1 over 9 PL square. We can now evaluate the deflection under the load, setting x equals A and A is L over 3, and using this equation here. And L over 3 minus L over 3, this term will be 0. So EI delta P equals P over 6 times L over 3 cubed plus C sub 1, which is negative 1 over 9 PL square times XL over 3. So simplifying, delta P is equal to negative 5 PL cubed over 162 EI. For the deflection at the center, we simply set X equals L over 2 in this equation here. So EI delta at center is P over 6 times L over 2 cubed minus P over 6 quantity L over 2 minus L over 3 cubed plus negative 1 over 9 PL square times L over 2. So simplifying, the deflection at the center is equal to negative 23 PL cubed over 648 EI. So that's for part 1. For part 2, we have the same reactions P And the equation will just be, this will just change to L over 4. So Px minus P quantity x minus L over 4, integrating EIY P over 2x square minus P over 2 quantity x minus L over 4 square plus C sub 3. So we'll just use C sub 3 because it is not equal to C sub 1. This is a different case. Integrating further, EIY equals P over 6x cubed minus P over 6 quantity x minus L over 4 cubed plus C sub 3x. There's no C sub 4 again. So evaluating the value of Z sub 3 when x is L over 2, y prime is 0. So 0 equals P over 2 times L over 2 square minus P over 2 quantity L over 2 minus L over 4 square plus C sub 3. So solving for C sub 3 is negative 3 over 32 PL square. We can now evaluate the deflection under the load by setting x equals L over 4 and substituting in this equation. The second term would be 0 because of value of x. So EI delta P equals P over 6 L over 4 quantity cube plus negative 3 over 32 PL squared times L over 4. So delta P is equal to negative PL cube over 48 EI. Then at the center, x is L over 2. So EI delta at center is P over 6 L over 2 quantity cube minus P over 6 quantity L over 2 minus L over 4 quantity cube plus negative 3 over 32 PL squared times L over 2. So the deflection at the center for this case is equal to negative 11 PL cube over 384 EI. So that's it for this video. I hope that for those who haven't found out that or haven't realized that the beam deflects symmetrically and that the slope at the center is 0, then I hope that you will learn from this experience now. Although you can set the equation of the elastic curve up to this segment here, but it will definitely give you longer solution.